Welcome to the Encyclo, where knowledge meets wonder. This is Cosmic Curiosities, Episode 3, The Life of Stars from Dust to Supernova. Today we're turning our gaze to the night sky, not just to admire it, but to understand it. Because every twinkling star you see is part of an epic story, a story of birth, life, and death on a cosmic scale. Let's begin at the very start. How do stars form? Stars are born in vast, cold clouds of gas and dust called nebulae. These stellar nurseries are scattered throughout galaxies and can span hundreds of light-years across. Inside a nebula, a disturbance, like a shockwave from a nearby supernova, can trigger gravity to take over. Clumps of gas begin to collapse under their own weight, and as they do, they start to heat up. This collapsing ball of gas is called a protostar. It's not a star yet, but it's on its way. As the core gets hotter and denser, it reaches a critical point, about 10 million degrees Celsius. At this temperature, a powerful reaction begins, nuclear fusion. Hydrogen atoms fuse into helium, releasing enormous amounts of energy. And just like that, a star is born. Once fusion starts, the star enters the main sequence, the longest and most stable phase of its life. This is where our own sun is right now. Stars spend millions to billions of years in this phase, balancing the outward pressure of fusion with the inward pull of gravity. The size of the star determines how long it stays in this stage. Massive stars burn hot and bright, but fast. Smaller stars like red dwarfs burn slowly and can live for trillions of years. During this phase, stars shine steadily, powering planets and life, if any is lucky enough to be nearby. Eventually, a star runs out of hydrogen fuel in its core, and what happens next depends entirely on its mass. Let's start with medium-sized stars, like our sun. When fusion slows, gravity begins to win. The core contracts, and the outer layers expand into a glowing red giant. It's a beautiful but unstable phase. After shedding its outer layers into a glowing shell called a planetary nebula, the core remains, a dense, Earth-sized remnant known as a white dwarf. Over billions of years it will cool and fade into darkness, but for massive stars the end is far more dramatic. Massive stars, those more than 8 times the mass of the Sun, live fast and die spectacularly. When fusion can no longer hold the star up against gravity, the core collapses in seconds. The outer layers explode in a cataclysmic event called a supernova. Supernovae are among the most powerful explosions in the universe, briefly outshining entire galaxies. They also seed the cosmos with heavy elements like iron, gold, and uranium, elements that make up planets and even our bodies. What's left behind depends on what's left of the core. If it's massive enough, it collapses into a neutron star, a city-sized object with more mass than the Sun. If it's even more massive, the collapse continues until not even light can escape. This is how a black hole is born. The life and death of stars isn't just a cosmic story, it's our story. Everything around us, the calcium in our bones, the oxygen we breathe, the gold in our rings, was forged in the heart of a star or scattered by a supernova. Carl Sagan once said, "We are made of star stuff," and he meant it literally. Stars are the universe's alchemists, transforming simple hydrogen into the building blocks of life. So, the next time you look up at the night sky, remember, every star you see is living its own incredible journey, from birth in a nebula to its ultimate fate, billions of years later. Some will die quietly, others will go out in a blaze of glory, but all of them will leave something behind. This is the Encyclo, and you've been listening to Cosmic Curiosities Episode 3, The Birth and Death of Stars. If you enjoyed this episode, please like, share, and subscribe to help us bring more cosmic stories to curious minds. And until next time, keep wondering, keep learning, keep looking up, keep